Hi, so we have finished chapter 30. Now we go to chapter 29. But in general of this topic, we need to remember that we are talking about battery. We are learning the reactions taking place inside the battery. And battery can provide the flow of electron from the negative end of the battery, and then the electron will flow out from the negative electrode and then pass through the electronic devices like light bulb or lighter, and then go back to the positive electrode of the battery. And then why this end will be negative electron? Because some reaction which will give out electron will take place here. For example, what kind of reaction will give out electron? Under what process electron will be given out? Do you still remember oil rig? Oxidation is losing electron, reduction is gaining electron, right? So here oxidation reaction is taking place here. That's why the electron is given out. For example, magnesium is changing to magnesium ion plus 2 ion electron. That's why the electron will come out. On another side, reduction is taking place. That's why the electron will flow back and some chemical will gain it. For example, MnO4. And then I hope that you still remember this oxidizing agent will change to Mn2 plus, and then follow the steps how we balance the half ionic equation. Plus 4 water plus 8 hydrogen ion plus 5 electrons. So they gain electron. Okay, so this is the chemistry inside the battery redox reaction, right? So we will go to some simple chemical cells, which is chapter 29. Okay, now we will relate the device of the battery and the chemical and the redox reaction. Okay, so for the simple structure, for the common structure of a chemical cell, so here we have 3 examples. So this one, the first one with a light bulb and then 2 metals, copper, magnesium, and electrolytes. And then for the second one, also an electrolyte. The electrolyte means some aqueous solution which can conduct electricity. This one is ionic equation. Ionic compound. And solution of ionic compound. That's why it contains mobile ion and it can conduct electricity. Two different metal, and lemon. It also contains electrolyte. Electrolyte means some solution which can conduct electricity. Okay, some solution which can conduct electricity, and also in the process of conducting electricity, it will there will be some chemical change take place on it. So a simple chemical cell will consist metal couple. That means 2 strips of different metal and an electrolyte. This is the basic structure of a chemical cell. Okay, so here and before we start, we need to remember the use of voltmeter. If we connect the negative electrode to the negative electrode of the voltmeter correctly, if negative to negative, then the reading coming out will be positive. Okay, we have to know this, so we can use voltmeter to measure the voltage, and then so that we will know whether the zinc electrode or the copper electrode will be the negative electrode. Okay, so here we connect the zinc to the negative electrode and copper to the positive electrode, and then we found that the voltage is positive. Okay, when the voltage is positive, that means we connect it correctly. That means the zinc is negative electrode and the copper is positive electrode. That means the electron is flowing from coming out from zinc and going back to the copper electrode. Okay, very important. The positive or negative value of the or the negative or positive reading from the voltmeter can tell us the direction of the electrons. So the electrons comes out from the zinc and go back to copper, because zinc is the negative electrode and copper is the positive electrode. Okay, so we know that the electron is coming out from zinc. So what happens on zinc? We can look into this diagram. So this is zinc foil, which is made of zinc, and then the zinc loses electron. So what do you think what happened on zinc so that it can lose its electron? Oxidation is taking place, right? Because oil read, oxidation is losing electron. So zinc can only lose its electron to form zinc ion. So it must be the reaction taking place on the left hand side here. So the electron will come out and the electron will go on. The electron will pass through the light bulb and then go back to copper, so that the copper will have some electrons on it. And electron is negatively charged. In sulfuric acid, there is hydrogen ion and sulfate ion, which is negatively charged sulfate ion, and hydrogen ion, which is positive charge. Then which one do you think will be attracted by the negatively charged electrons? We know that opposite charge will attract each other, right? So it should not be sulfate, it should be hydrogen. So hydrogen will be attracted to the copper electrode, will be attracted to here. The hydrogen ion will be attracted to here, and then they will gain electron. And then what do you think will be formed? Yes, hydrogen gas. So they will gain electron to form hydrogen gas. And so we can fill in the table on another page. Zinc electrode. On zinc electrode, zinc will lose its electron because the electron is coming out from there, so that we know that it's negative electron. And for the observation, because zinc is losing electron and becomes zinc ion, it's losing electron and becomes zinc ion. So the zinc ion, oh my bad, here it should be zinc 2 plus, okay? Zinc ion, okay? So I write it again. Zinc loses electron and becomes zinc ion. And the zinc ion will dissolve in the solution. So can you see here should be zinc electron will dissolve. You will see that the zinc electron become more and become smaller and smaller, and because it's losing electron, okay, losing electron, so it is reducing agent. Okay, on another side it's opposite, so here must be opposite, positive. And as we said before, hydrogen gas. Here, hydrogen gas is given out, right? Because the hydrogen ion will come and gain electron to form hydrogen gas. So here, colorless gas bubbles evolved, or you may say formed, okay? And then hydrogen ion comes to here to gain electron to form hydrogen gas. It's oxidizing agent. And then now you can combine these two chemical equations, because both sides has 2 electrons, so you can write it directly. Zinc plus 2 hydrogen ion change to zinc 2 plus and hydrogen gas, okay? And then in zinc copper cell, in this chemical cell, which metal will be the negative electron? The voltmeter tell us that it's zinc, because zinc is connected to the negative electron of the voltmeter, and then it gives us a positive value, a positive reading. So zinc is the negative electron. And according to what you know, why it's zinc losing electron but not copper? Why zinc will preferentially loses electron but not copper? According to what you have learned in Form 4, the chapter for metals, can you explain why zinc will loses electron but not copper? It's because in the metal reactivity series, zinc is above copper, and then that means zinc is more reactive than copper. So zinc will loses electron more readily, okay? And you can also refer it to ECS. On ECS, the electrochemical series, zinc is also higher than copper, so zinc will has higher tendency to lose electron, because zinc is higher in ECS than copper. Or you may say zinc is more reactive than copper. Zinc loses electron more readily. Okay. And last question, what are the changes to the electrolyte when the cell discharge for a long period of time? So we will go back to here. What do you think it will be formed? Originally there is hydrogen ion and sulfate ion, but hydrogen ion is discharged. Hydrogen ion gain electron and form hydrogen gas on the copper electrode, so no more hydrogen ion. But zinc ion is formed from the zinc foil, so there will be zinc ion and sulfate ion. So gradually the electrolyte will change to zinc sulfate gradually. Okay, it would the concentration of zinc sulfate will be higher, and pH, because it's no longer sulfuric acid, the hydrogen ion, the concentration of hydrogen ion is getting lower and lower, so the pH now it will be less acidic. Okay, it will be less acidic, so pH will higher, will increase, because it's now it will not be that acidic as before. It will not as acidic as before. Okay, so what you need to do is this one, magnesium copper cell, very similar, it's also made of two different metals. So I think you can complete this table by yourself, and given that the voltage is plus 1.3, and even I don't give you the voltage, but you can still predict it. The voltage will be zero. The voltage will be zero, positive value or negative value, because you know that magnesium and copper, which one is more reactive, right? Which one is stronger reducing agent? And complete this table and complete these 3 questions in the class practice as homework. Okay, and this question will be quite difficult, but a good try for you. Try to answer it. Why the zinc copper cell, the voltage is just 0.92. For this cell, the voltage is just 0.92, but for this cell it's 1.3. Why the voltage of the magnesium cell will be higher than that of zinc, while both of them using copper? Okay, so try to answer it.